We start off with the customer IT persona in the Azure portal Azure IoT Operations blade. The user is able to manage registry endpoints with MCR and ACR to enable OT for connectors and data flow graphs. The user can manage and enable connectors by selecting from various available connectors, including OnViv, Media, REST, SSE, and MQTT. You are seeing a connector being selected, and the user is given the option to make changes from the original metadata created by the developer persona. This screen shows integration with ACSA and volume claims, and Azure Key Vault to secure trust credentials for server-to-server interaction. Here, existing trust credentials are being picked from AKV during connector setup. Once saved, this connector will be available for the OT to use. We move next to the Azure Device Registry blade to show how AIO and ADR integrate, with namespaces and assets from AIO showing up in the ADR experience. Here is the operations portal for OT. Clicking on Devices, the user will be able to see all of the connector tiles which IT has enabled. A new device inbound endpoint is being created to connect to the southbound resource, which can be an OPC-UA server, a camera, REST, or SSE server. The user selects the HTTP REST connector to create a device inbound endpoint. Customers can add metadata to identify the device with filtering. When saved, the connector will be deployed as a pod. Right away, we can see a new pod has been created, and this connector is now running.
Clicking on Discovery, the user can bring a discovered device into operation by importing it. On import, the OT user will see the device view populated with the discovered device details. Discovered assets can be imported here as well. When creating a new asset, OTs will choose which device inbound endpoint to associate with it. We'll choose an OPC-UA endpoint here. After selection, the view populates with the steps relevant to the chosen endpoint. In this case, OPC-UA has datasets, event groups, and management groups, so we see those steps appear. Going back to a clean asset view, we'll choose a media endpoint this time. Looking at the sidebar, we can see that the media endpoint supports streams, so we're able to configure that. Switching to the Details view for an existing asset, we can manage the datasets by switching to its tab. Users can now group multiple data points into datasets, where each dataset can have a different sampling and publishing interval. Event groups can be managed here as well, in addition to management groups, which adds support for inner loop. This allows users to configure actions to fire without human intervention. Those actions can be edited by clicking the name. OpenTelemetry has been added as a northbound endpoint, enabling integration with Azure Monitor. Data flow graphs is a new feature where a developer can build complex transformations to make available for OT users in DOE. Here, the OT is able to see pre-created graphs enabled with Azure Container Registry and registry endpoints. Now you're seeing an existing data flow graph, which captures a temperature metric, transforms the data with a developer-created graph, and sends it to the new OpenTelemetry endpoint. We can view that endpoint here. The user can view telemetry metrics from the temperature data being sent through the data flow graph using a pre-built Grafana dashboard. The dashboard can be found by clicking the link. Once the dashboard loads, the user can view the telemetry showing data going through the data flow graph into the OpenTelemetry endpoint. That telemetry can be viewed here. Thank you.